So welcome back after the lunch. Dear audience, now we have a culinary session that is higher education and research in local and global context. In this plenary session, the leading role will be played by Dr. Michael Lahr. Dr. Michael Lahr is the Director of Economic Advisory Services. He is an expert of input-output analysis. Presently, he is the Vice President of International Input-Output Association and Chair of Benjamin H. Stevens Graduate Fellowship of North American Regional Sciences. And along with him, there is Dr. Sukkur. He is Professor at Sindh IB of Marketing, and then Dr. Imtiaz Arif, he is a professor at Ikra University of Finance, and then Dr. Usman Raja is working in the business school in the Canada. So we will have a lead panelist over here, Dr. Michael Lahr. I would request him to please have a seat.
First of all, I want to make it clear that I'm not the person that Dr. Asharaf talked about earlier. I may not give good talks, but I do well enough most of the time. One of my issues, though, when I first gave a talk, I was a little nervous, especially in front of a large crowd. I was taught, I said, I'm going to have to give a talk. I'm not sure everyone will know what I'm talking about. And my boss, Professor Greenberg, said, well, just make sure you wear a nice tie. So, if you don't like the talk, I hope you like the tie. Well, what I'm going to talk about today is the input-output experiences. It's about half of my job is doing research with input-output. As I was mentioned, I'm the vice president, but right now currently the acting president of the Input-Output Association International, and we'll be meeting in Atlantic City this year if you want to come. So I have to say those kind of things. So let me talk generally about what input-output is. I'll get into some discussion of how to use it, and then I may try to skim through an example from Egypt that may be relevant here. These are the I/O fundamentals. This is an input-output table. You can see it right there. It shows basically just all the industries, agricultural through services and other, maybe even government. And then we have final demand. And what it really is meant to do, and do we have a pointer here? Is there a pointer?
Yeah, right.
This? Which? There, okay, thank you. So the idea behind the idea behind input-output analysis is to make sure that this stuff here, which is the employee compensation, profit, and indirect business taxes, sums up to these here. So it's kind of a double accounting technique, but the governments use it. And the idea is to come up with some estimate of gross domestic product. This total should equal this total. And we use this part just to subtract out. These are the materials and equipment and other services that are used. And that's really what it's basically used for. I don't think Pakistan has produced one since 1976. So it's not something that's standard here anymore. India has one fairly recently from 2008. A lot of, U.S. most recent one is 2007. One is being now produced for 2012. They're produced every 5 years to benchmark GDP. That's the whole point of them. But what I'm going to do is not talk about GDP at all. I'm going to be talking about other things, because rather than use the part that the governments really want, which is this and this, I use the garbage, this part right here, okay? So that's what we use for modeling, and I'll show you in a minute by demonstrating what it is. And the whole idea is it's the best way to demonstrate inter-industry dependencies. And you can imagine if we have this for one country, now we have global input-output tables. There are some manufactured for Pakistan, and I'll talk about that in a little bit. Okay, so this set of equations here is really the way we derive this, just so you get, you don't need to memorize this, no quizzes, okay? So this is just to give you some idea of how you have X, which is the output right here. These X's are the sum of the Z's, which are that inter-industry stuff, plus the final demand, okay? So we can represent these in matrix form as X, Z, and F, just for a quick thing. You don't need to know this, remember. This is just so I can go through my stuff quickly. And the idea is now that X equals this matrix Z summed across the rows plus F. And that's all this is. So this is conventional supply side equation. I'm saying this is supply because we're going across this way on the input-output table back here. Come on, I have to go this way. So what I'm doing is adding across, going across this row like this. This would be the demand side equation, okay? And I'll talk about that in a little bit. Okay, so what we have here, the advantages of input-output is, as far as a modeling tool, is that it has a lot of sectoral detail. It has inter-industry connections that are quite explicit. If you use econometrics, some are explicit, some are not. They theoretically, therefore, should have the best multiplier effects estimates. So when we're talking multiplier effects, it's you have some direct effect on the economy. We can see what other suppliers, if you have some demand, there's some suppliers who must provide that demand. Those suppliers have suppliers, and those suppliers have suppliers that supply those suppliers. So and it continues on. So we have many multifold effects on the economy, and that's what we're trying to estimate here for various reasons, and I'll talk about that again later. The problems with input-output is that, first of all, it's the tables are old. As I mentioned, even in the US, the 2007 tables are current here in 2016. 2012 won't come out until next year. Pakistan's are 1976, but people have updated them to 1996 and so forth using some other techniques that people in my field use. And finally, it has fixed technology and it's average technology. So the idea is you can't really, it doesn't change over time, and it's, you're not dealing with the marginal technology, which is most economists are usually interested in. Again, I'm speaking it from this as if I'm an economist here. This is one of the coefficients called a technical coefficient, and it just gives one particular example. This is from Miller and Blair. It just says the value of what share of total inputs into the aircraft industry is that from aluminum. Okay, so that's one of them. This just, ultimately we can therefore get a production functions from this immediately. So this is a set of data that's also a model, which is kind of nice. And this leads us to this formulation. We assume A is the technical coefficients matrix. All we're saying is that Z, those inter-industry transactions divided along the columns by output equals the production function. The kind of simple thing. It looks tough on the math. So this is what I'm saying. Ultimately, if you have this matrix here, which is something we fabricated some time ago, up here, this 10 here translates into 10 divided by 100, which is 0.1. And so we can say that this is 10% of all inputs into the agricultural sector here is agriculture, 40% is manufacturing, 15% is services, 15% other, and then there's some other things like labor wages and so forth that are included, which we're excluding for the moment. But the idea is this is, if you think about it as a recipe, this is what it is. No matter what, if this is in dollars, this is in shares. And if this is in rupees, this is in shares. If this is in Rial, whatever it is, euros, doesn't matter. These things are all standardized across nations, more or less, and it doesn't really matter. This has no monetary units in it whatsoever, although this is all monetary, okay? So this is the idea behind this. So I'm just showing you now that this is the same as, this is Z up here, and this is the X here, so all I'm doing is showing the result. So this now, I've already presented this formula to you, originally. And I presented this one just now, so that substituting this into here yields this, X equals AX plus F. And now I have this thing solving for what F is. F equals I minus AX, just pulling things out, just mathematically. This is very simple rudimentary mathematics I had in like 7th grade. I'm sure you guys did too. You may have forgotten it though. Okay, so the idea here is now what I can do is to develop, just by moving things around and solving for X. Remember, we were back here. That was this. All I do is now move this over here, which makes it an inverse matrix, and solve for X. I can now do this, and I get this model. And this is significant because this now is this matrix, this I minus A inverse, is called the Leontief matrix, because Vasily Leontief, who was a Russian expatriate that came to the United States eventually, showed that this is now the multiplier effect. That is, for each rupee or dollar that you put into the economy in agriculture, you get 3.3 back in net. through to all that supplier stuff. And if I wanted to go into other mathematics, I could show you how this is equal to a power series approximation that's equal to the ripple effects, and we don't need to worry about that for now. But the idea is, this is what we're talking about, and what most economists are interested in input-output tables about, is these multipliers and the Leontief matrix. So now I've taught you the rudimentaries of it. I want to get into what we can use some of these things for. And so just the transaction matrix, the Z, we use to estimate, you can use for various things. When I was working for a company, I used it to help me get a generalized estimate of the market for man-made diamond cutting tools. I had no way to get the information, but I could look at the input-output matrix. I think Pakistan's is maybe 26 sectors. The US has one with 380 right now, so I can get pretty much detail. I think India's has 120, just so you get an idea of scale. Different nations have different detail. Also, at one point, I wanted to know how much sheep. There are two, we have a sheep sector, sheep production sector. Well, how much of it is sold for wool versus for meat? This is something else I could make an estimate of from this table, because we know what the markets are. So if I know it's being sold to slaughter, it's probably being for meat, okay? If it's being used for something else, probably it's for hair, the wool. And finally, I could also, for example, I'm doing some work now with people in India looking at the sugarcane production for gasohol, and I can get some idea what it is, because fortunately India, like Pakistan, doesn't have much of an alcohol industry. In the US we do, and so does Brazil. So when I'm looking at the market for sugarcane, I have to worry about the market for alcohol in things like rum and so forth. So in this case, it's not the situation. Almost all of it's used for gasohol. Gasohol is an increasing market for sugarcane in India, and it's the way they're going to try to move towards being more green. So let me move further. The next thing is using the technical coefficients. We use them for estimating significant costs that might vary across geography. So if I want to look at how steel is made in different areas, and I can find out what's causing the differences in, say, production in China versus US, well, I can see that it's coal. They use much more coal in China than they do in the US, which is used as an electric arc furnace, for example. I can also estimate, in the US, I'm doing things to estimate household consumption by state. Well, I need to use the original data from the US table and the personal consumption data and get them reconciled, and then I can now do an estimate for states. I can find out which industries are most resource-oriented, if that's something I'm worried about. So if you're worried about some new resource tax, we can find out what industries are going to be affected most by that. I can also use energy resources by industry. I've used those particular coefficients in regression work when I'm doing some research for that. Closeness of industries. There's some ways in econometrics to weight different industries, and if you want to weight them by the closeness they are to each other, for example, for doing cluster analysis, to doing development work, this would be one way to do that as well. So we use the input-output coefficients for that. And finally, measuring vertical specialization. If you have a multi-regional table across countries of the world, you can see how labor in one increases in production in one region, increased labor use in another one. So this is something Pakistan publishing needs to look at more, is when it's doing its own development, how is it affecting the rest of the world, and how is the rest of the world affecting it? It might change their policies, international policies, for example. Finally, there's multipliers, and these are, conventional one is economic impact analysis, and if I go back a couple things here, all I need to do here is, in this case, change this F here. If I change the final demand, that is, if government spends a little bit more or some new kind of production goes on, I can find out what the change in output level will be. Total input output, you can find out the multiplier effects from that. So that's one basic, I think I make most of my money in my institute doing this. So this is one of the things I do a lot just for my state of New Jersey, and there's other people competing in the US. I can look at the analysis of government tax policies. And I've just done that recently. We had a change in our gas tax. I'm looking at the effect of that, as well as at the same time to decrease the sales tax, see what the net effect in our fiscal policy is. And that's the sort of thing we can do with these kind of models as well. We can do something called key industry analysis, which shows you the most important industries in your economy. You can do target industry analysis, where you find out those industries that are most likely to induce development in your region or country. We can look at use the multipliers here to gauge forecasting models to make sure their impacts are proper. We can measure value change, that is, find out how much, for example, there's a trade deficit between the U.S. and China, but it's, 4-to-1 deficit, but it's really more like 2-to-1 because U.S., when it's importing those things from China, gets very low value-added products, that is, has low profit margin, while those in the U.S. going to China have a high profit margin. So it's really, that causes a difference there. And you can also analyze things the same way I mentioned with employment. Finally, we can look at how international environmental policies are affecting things here. And one of the things, for example, I've seen somebody do is seeing how trade policy affects matters. And for example, down near Seville in Spain, they're exporting water, and it's a desert country. This should not be happening, right? Desert countries should not be exporting their water. They do it in the form of clementines, which are like oranges. And it's not a wise choice for them to be exporting their water because they have such problems with that. So we can also look at effects of CO2 across nations. So this is really one of the hot topics right now, is using it for international environmental spillover and feedbacks. And one of your professors here, Professor Niaz, is doing that kind of work here. And that's one of the reasons I came here, by the way, and thank you, Niaz. I just want to, let me say something further on that, which is if you go to a conference and make some comments on somebody's paper, be forewarned, they may be knocking at your door coming to visit, and then inviting you over to their country another time later. So we become good friends. And the other thing is we can also look at what's causing structural change. So if you have more than one input-output table, we can find out what parts of the input-output table are causing those changes. Is it changes in productivity? Is it changes in the type of final demand? And I've been doing that kind of work in China and determining that the changing final demand structures in China are causing great changes there. And since they're talking about becoming more of a domestic-oriented economy rather than an export one, that will change things greatly in their economy. They've only been able to do that now since they vaulted themselves through increases in income through their export policies. So let me go, I'm pretty much using up my time now. I'm going to go through another 5 minutes quickly in the next 20 slides, so I'll be zipping through. This is another presentation I did with one of my students from Egypt, Dina El Shahawane, and also a friend of mine from Brazil. And this is looking at a proposed corridor, something similar to going down along the Nile, something similar that would be to something that would be much better than what I currently saw along the Indus yesterday. So this is just showing there's a need for this road, and this is what's showing you how densely populated along these governorates of Egypt they are. You can see almost everything's along the Nile, especially in the delta and the northern end there. This is showing you the highway that we're proposing. Is this highway here that's going to be out in the desert and linking things, the major cities along here. Right now, all the highways are right on the Nile, and it's highly congested. You can't really move around much. It's a real problem. So the idea they're moving would have electricity and water flowing, going up and down the Nile. And we wanted to see, this is something somebody's, kind of a pie in the sky thing somebody wanted to propose it. His name is El Farouk Al-Baz. I think he's up at Boston College in the United States right now. Anyway, so let me move through this quickly. This is the question we're going to answer, and we use what's here as an input-output table, but we use a highway project. We then looked at the road network. We connected the road network to the governorates. It's quite a large project. We use GIS and input-output together, and along with something called CGE modeling, which is using an input-output table and then optimizing it for consumer behavior. And we then this is linking it to the road system. So this is, and then saw what the change in travel times was. This shows you, I'm not going to go through this here. We had some rules that we used for guiding us in our judgment of how to reduce the cost of travel time. And this is showing then the time savings by a government. You can see those that are most remote had the greatest time savings. This is just a kind of a gravity model formulation. For those who know what that is, that's just like the gravity model for planets. And then we integrated this together with the model, and we saw how the transportation changes would affect production and production levels. And this is something we used to show how transportations, we had to derive our own elasticities for those who are economists. We entered those into the model, which is the effective rate for the short run, that is when we assume that people cannot migrate. And when we do have migration, then we had a slightly different set of elasticities here. And then we took a look at the, I guess that was it. So then we did an impact run on the CGE model, and this is what we got in terms of change in GRP. We can show those areas which had the greatest time savings, got the greatest benefits, and we can see there are some other changes in the long run, household consumption-wise, regional investment-wise, and the idea was we're improving the most backward areas of Egypt, and we're getting it less congested in the center, and at the same time. So all this was looking like positive things, increased exports from the interior, and so in the end, I just wanted to say that this yielded, the corridor was supposed to yield strong positive effects. So this is one of the more complex ways to use input-output tables. In the end, so I just wanted to give you a flavor of what one complex method looked like. This took about a half a year to do, a little more. So with this, I give you a blessing, which is from Lake Wobegon, which is a radio show in the United States. It says, may your women be strong, your men be good looking, and your children be above average, and may peace be with you.
Thank you, Dr. Michael Lahr. And Michael Lahr was sharing with you about the input-output analysis which you can use to analyze the different sectors of the economy.